Hello again. Today we're going to be writing a proof. This time we are going to do a 2-column proof. So here I am given that line segment ST is congruent to line segment VW. I am also given that line segment TU is congruent to line segment WX. We are being asked to prove that line segment SU is congruent to line segment VX. So let's get started. Like I said, we're doing a 2-column proof, so we will be needing a table to do our 2-column proof. So here we have our table, and at the top of the left column will be my statements. And on the right column will be the reasons. So my first statement is that line segment ST is congruent to line segment VW and line segment TU is congruent to line segment WX. And what's the reason for that? Well, the reason is given. Now be mindful that I'm putting these numbers in front because I need to number my statements and reasons. So remember to do that. Next, statement number 2 is that the measure of line segment ST is equal to the measure of line segment VW, and the measure of line segment TU is equal to the measure of line segment WX. Remember that the way you write the measure of for line segments is simply to remove the bar from above the line segments. And that is the shorthand for writing the measure of a line segment. And the reason for that is definition of congruent line segments. Remember, the definition of congruent line segments says that if 2 line segments are congruent, they have the same measure. Next, I can add ST plus TU, and that makes line segment SU. I can also add VW plus WX, and that makes line segment VX. And the reason for that is the segment addition postulate. Next, I can say that VW plus WX is equal to SU because what I'm doing is I'm taking this part of this equation and this part of this equation and I'm substituting them. So the reason for that is substitution. Next, I know that VW plus WX equals VX. So I can drop that down in for statement 5 as VX equals SU. And the reason for that is the segment addition postulate. Now I know that the measure of VX equals the measure of SU. And let's refer back to our proof statement. It says that line segment SU is congruent to line segment VX. Well, I'm going to flip that around to say that the measure of line segment SU is equal to the measure of line segment VX. And I can flip that around because of the symmetric property of equality. Now we're almost there. So I know that the measure of these 2 line segments are the same. So I can say that they are congruent. So line segment SU is congruent to line segment VX. And the reason for that is the definition of congruent line segments. And that's how you write a 2-column proof to prove that line segment SU is congruent to line segment VX.